of nitrogen. Properties of nitrogen. Dinitrogen is colorless. Dinitrogen is colorless, odorless, tasteless, and non-toxic gas. Odorless, tasteless, and non-toxic gas. These are slightly soluble in water. So one is slightly soluble in water. Slightly soluble in water. Here two isotopes. Two isotopes are present. What are these two isotopes means? 7 nitrogen 14 is available, 7 nitrogen 15 is available. Two types of isotopes. Then dinitrogen is chemically inert. Dinitrogen is chemically inert. What is the meaning of chemically inert? Means does not involve in chemical reaction. What is the reason? Means yesterday discussed already. This is high bond dissociation energy. Due to high bond dissociation energy, this nitrogen is chemically inert. Next, nitrogen react with metals. Nitrogen react with metals to form corresponding metal nitrides. Corresponding metal nitrides. 6 moles of lithium. 6 moles of lithium react with nitrogen. 6 moles of lithium react with nitrogen to form Li3N, lithium nitride. Then magnesium react with nitrogen to form magnesium nitride. So that is general form of metal nitride. Lithium gives lithium nitride, magnesium gives magnesium nitride. Here the very important process is Haber's process. Haber's process. What is Haber's process? Means nitrogen react with 3 moles of H2 to form 2 moles of NH3. N2 plus 3H2 gives rise to 2NH3. Industrial preparation of ammonia, that is named as Haber's process. Here delta H equal to negative. Delta H negative indicates exothermic reaction. As well as this reaction is reversible also. This reaction takes place in the presence of iron catalyst. This reaction takes place in the presence of iron catalyst. Next, reaction with oxygen. Reaction with oxygen. Reaction with oxygen. Here nitrogen N2 react with oxygen to form 2NO. This reaction takes place around 2000 Kelvin temperature. Why? Because here nitrogen is triple bond O. Oxygen is double bond O. Actually here the bond between nitrogen and oxygen. That means these 3 bonds undergoes breakup, cleavage. These two bonds also undergoes cleavage. All bonds undergoes cleavage means more energy required. That's why very high temperature only that nitric oxide formed. NO. Nitrogen monoxide or simply nitric oxide. నేను ఇక్కడ అసలు జస్ట్ ఓన్లీ హియర్ డిస్కషన్ అబౌట్ ప్రాపర్టీస్ నేను హియర్ నాట్ ఎక్స్ప్లెయినింగ్ ఫేవరబుల్ కండిషన్స్ లైక్ జస్ట్ ఓన్లీ ఐరన్ టెంపరేచర్ ప్రెషర్ దట్ ఈస్ నాట్ ఎక్స్ప్లెయినింగ్ ఓన్లీ నెక్స్ట్ కాన్సెప్ట్ అమోనియా ప్రిపరేషన్ ఇన్ దట్ కేస్ డయాగ్రామ్ ఆల్సో నో నీడ్ ఐ థింక్ కావాలా 1 మార్క్ రైట్ uses nitrogen mainly used in the manufacture of ammonia. Nitrogen mainly used in the manufacture of ammonia and industrial chemicals containing nitrogen. Industrial chemical containing nitrogen. Industrial chemical containing nitrogen. And next thing is to provide inert atmosphere. To provide inert atmosphere. To provide inert atmosphere in the metallurgy of iron. In the metallurgy of iron. To preserve biological materials and food items. To preserve biological specimens and food items. Lace packet. Inside air there, that air is this nitrogen. Nitrogen is not reacted at ordinary temperature. Like this nitrogen reacted means nearly 500 degrees temperature or at least 400 degrees temperature. Room temperature is nothing but maximum 50 degrees. Normally room temperature means 25 to 27. In summer time maybe full summer అయినా కానీ మ్యాక్సిమం టెంపరేచర్ 50 degrees. దట్స్ వై ద ఫుడ్ ఐటమ్ ఈజ్ నాట్ రియాక్ట్ విత్ కవర్. ఆ ప్లాస్టిక్ కవర్ ఉంటుంది కదా, దట్ ప్లాస్టిక్ కవర్ విల్ నాట్ రియాక్టెడ్ విత్ ఫుడ్ ఐటమ్ విత్ ద ప్రజెన్స్ ఆఫ్ నైట్రోస్. రైట్. నెక్స్ట్ మెటలర్జీ మీన్స్ ఎక్స్ట్రాక్షన్ ఆఫ్ మెటల్ ఫ్రమ్ న్యాచురల్ సోర్స్. Extraction of metal from natural source is called metallurgy. Next the topic is ammonia. Ammonia is present in air and soil. Ammonia is present in air and soil in small amounts. Next, ammonia is prepared by the thermal decomposition of urea. By the thermal decomposition of urea. So here urea formula NH2 bond CO bond NH2, which is dissolved in water molecule to form NH4 taken twice CO3. That is named as ammonium carbonate. This ammonium carbonate on strong heating it loses water molecule and form carbon dioxide and ammonia and carbon dioxide and water. This one is urea, the first organic compound. The first organic compound prepared in laboratory. The first organic compound prepared in laboratory in urea, NH2 bond CO, NH2. This is dissolved in water to form ammonium carbonate. That ammonium carbonate on strong heating gives ammonia. Next nana, ammonium salt. Ammonium salt treated with lime or caustic soda. Ammonium salt. Ammonium salt treated with lime or caustic soda. Lime or caustic soda to form ammonia gas. So here ammonium chloride NH4Cl. Lime means CaOH taken twice. Calcium hydroxide. If we take 2 moles, your compound is 2 moles of NH3, calcium chloride, and the byproduct is H2, like that. So if we take one more ammonium salt, NH4 taken twice, SO4. Here caustic soda. The caustic soda formula is NaOH. To form the product is NH3 and byproduct is Na2SO4. This sodium, this sulfate, Na2SO4. This calcium, this chlorine, calcium chloride. And what is the byproduct means? Here also H2O is the byproduct. So this ammonium salts are react with lime or caustic soda to form ammonia. Okay, on large amount. Next, on large amount ammonia is prepared in Haber's process. On large amount ammonia, on large amount ammonia prepared in Haber's process. So here what is Haber's process means? In this Haber's process, N2 plus 3H2 equilibrium to NH3 delta H equal to minus 46.1 kilojoule per mole. Here how many moles of reactants? 1 mole of N2, 3 moles of H2, 4 moles of reactants converted to 2 moles of products. 4 moles of reactants converted to 2 moles. That means volume decrease or increase. So that means volume decrease. Volume decreases means 100% pressure increases according to Boyle's law. What is Boyle's law? P is inversely proportional to 1 by V. That's why according to forward given equilibrium, in forward reaction 4 moles of reactants converted to 2 moles. That means volume decrease. Volume decrease means pressure increase. Here using the pressure is 200 atmospheres pressure. 200 atmosphere pressure. Next, in the forward reaction, effect of temperature and side heading rain. Effect of temperature. This is effect of pressure. Effect of temperature. In forward reaction, delta H is delta H is negative. In forward reaction, delta H is negative. That means exothermic reaction. But exothermic reactions takes place at low temperature. Exothermic reactions takes place at low temperature. But at low temperature, the reaction is low temperature, the reaction takes place very slow. The reaction takes place very slow. So optimum temperatures are used. The optimum temperature is 773 Kelvin. Optimum temperatures are used. Next, the catalyst is iron. Iron is catalyst. Nowadays, iron oxide with small amounts of K2O. Iron oxide with small amount of K2O and Al2O3. Al2O3 is used as a catalyst. Al2O3 is used as a catalyst.